NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve logarithmic equations by converting them to exponential form. We'll use the key rule, log base a of f of x equals b if and only if f of x equals a to the power b. We'll apply it to several quick examples and check domains. Before using the rule, remember the conditions. The base must be positive and not equal to 1. And the argument of the logarithm f of x must be strictly positive. In this lesson, we will solve two logarithmic equations step by step, exactly following the structure shown on screen. We begin with an example. Our two equations are log base 3 of x equals 4 and log base 2 of the quantity x minus 1 equals -1. Problem 1. Convert the logarithmic equation to its equivalent exponential form using the rule. Log base b of it equals c if and only if it equals b to the c. Applying the rule gives x equals 3 to the 4th power. Now evaluate 3 to the 4th as 81. So x equals 81. Quick challenge. Before we start problem 2, can you predict the first algebraic move? Problem 2. Again, convert from logarithmic to exponential form. We get x minus 1 equals 2 to the -1. Use the negative exponent rule. b to the minus c equals 1 over b to the c. So x minus 1 equals 1/2. Add 1 to both sides to isolate x. Finally, write 1 as 2 over 2 and combine to get x equals 3 over 2. Quick domain check x must be greater than 1, and 3 over 2 satisfies that condition. Summary. We used two consistent moves. Convert log to exponential, then simplify. Final answers are x equals 81 and x equals 3/2. Practice a few more to master the pattern. Example 1. We start with log base 0.01 of x equals 1/2. Use the definition of a logarithm to convert to exponential form. A log base b of it equals c if and only if it equals b to the c power. Therefore, x equals 0.01 to the 1/2. Rewrite the base as a fraction. 0.01 equals 1 over 100. Now, x equals open parenthesis, 1 over 100 close parenthesis to the 1/2. A 1/2 power means square root, so x equals the square root of 1 over 100. Finally, simplify the root to get x equals 1 over 10. Great! We solved the first equation carefully without skipping steps. Now we apply the same algorithm to the second equation. Example 2. We start with log base 9 of x equals 3/2. Again, convert to exponential form using the same rule. So x equals 9 to the 3/2. Express the base 9 as 3 squared. Therefore, x equals open parenthesis 3 squared close parenthesis to the 3/2. Use the power of a power rule to multiply exponents 2 times 3/2, which equals 3, yielding x equals 3 cubed. Compute the value to get x equals 27. Example. We will solve the logarithmic equation. Log base 5 of, open parenthesis, 2x plus 4, close parenthesis, equals 2. Step 1. Convert the logarithmic equation to exponential form. We use the rule, log base b of it equals c, if and only if a equals b to the c. Applying the rule, here gives 2x plus 4 equals 5 squared. Step 2. Evaluate the exponent. 5 squared equals 25. So our equation becomes 2x plus 4 equals 25. Step 3. Isolate the term with x. Use the subtraction property of equality. If a plus b equals c, then it equals c minus b. Subtract 4 from both sides to get 2x equals 25 minus 4, which simplifies to 2x equals 21. Step 4. Solve for x by dividing both sides by 2. The division property of equality says, ax equals b implies x equals b over a. Therefore, x equals 21 over 2. Always check the domain of a logarithm. The argument 2x plus 4 must be positive, so 2x plus 4 is greater than 0, which means x is greater than -2. Our solution x equals 21 over 2 satisfies this condition. Quick verification. Plug in 2 times 21 over 2 plus 4 equals 25, and log base 5 of 25 equals 2. Final answer x equals 21 over 2. We will start from the original equation, Then transform it line by line until we get the valid solution. Step 1. Add log of x minus 3 to both sides to gather the logarithms on the left. This is just the addition property of equality with a focus on logarithms. So we get log x plus log of x minus 3 equals 1. Step 2. Apply the product rule for logarithms. The sum of logs becomes the log of a product. Therefore, we have log of x times x minus 3 equals 1. Step 3. Convert the logarithmic equation to its exponential form using base 10. If log base 10 of a equals b, then a equals 10 to the b. Hence, x times x minus 3 equals 10 to the first power. Step 4. Expand the left side and bring 10 to the left to set the quadratic equal to 0. We obtain x squared minus 3x minus 10 equals 0. Step 5. Factor the quadratic. It factors as x minus 5 times x plus 2 equals 0. So our candidate solutions are x equals negative 2 and x equals 5. Step 6. Check the domain for logarithms. The arguments of both logs must be positive. That means x greater than 0 and x minus 3 greater than 0. So overall x must be greater than 3. On a number line, shade the region to the right of 3. Test our candidates. Negative 2 is not allowed, while 5 is valid. Therefore, the solution is x equals 5 only. Example. First problem. Log base 1/10 of open parenthesis x squared minus 1 close parenthesis equals negative 1. Step 1. Convert from logarithmic to exponential form. The argument equals the base raised to the power on the right. Step 2. Rewrite 1 over 10 as 10 to the power negative 1. Step 3. Simplify the power of a power to get 10 to the first power, which is 10. Step 4. Add 1 to both sides. Step 5. Take the square root of both sides. We must include both the positive and negative roots. Finally, both answers are acceptable because x squared minus 1 is positive for both values. Example. Second problem. Log of open parenthesis. Example. Second problem. Log of open parenthesis 2x minus 5 close parenthesis squared equals 0. Step 1. Convert to exponential form with base 10. Step 2. 10 to the 0 is 1. Step 3. Take the square root of both sides. The left becomes an absolute value. Step 4. Split the absolute value equation into two linear cases and solve. Therefore, the solution set is 2 and 3. Solve. Therefore, the solution set is 2 and 3. Example 1. We begin with the equation. The log of 2 divided by 1 minus log of x equals 1/3. Now, we will follow the provided sequence of algebraic steps exactly, explaining each rule on the way. Step 1. Cross multiply. We get 1 minus log of x equals 3 times log 2. Step 2. Use the power rule. 3 times log 2 becomes log of 2 to the third. So we write 1 minus log x equals log of 2 cubed. Step 3. Simplify 2 cubed to 8 and move negative log x to the right side. That gives log 8 plus log x equals 1. Step 4. Apply the product rule of logarithms. The sum of logs equals the log of a product. So we get log of 8x equals 1. Step 5. Convert from logarithmic to exponential form. For common log base 10. Log of something equals 1 means that something equals 10 to the first. So 8x equals 10 to the first power. Step 6. Simplify the right side to 10. Step 7. Divide both sides by 8. Step 8. Reduce the fraction to 5/4. Finally, write the solution set. D equals the set containing 5/4. Domain check. For common logarithms, we require x greater than 0, and the denominator 1 minus log x must not be 0, so log x cannot equal 1 or x cannot be 10. Our solution x equals 5/4 is positive and not equal to 10, so it is valid. Example 2. Now, solve the nested logarithm. Log base 3 of x of 3 equals 2. We will again follow the exact sequence of steps from the worked algorithm. Step 1. Use the reciprocal change of base idea. Log with base a of b equals 1 over log base b of a. So 1 over log base 3 of x equals 2. Step 2. Take reciprocals of both sides. Then log base 3 of log base 3 of x equals 1/2. Step 3. Convert this logarithm to exponential form. The inside equals 3 to the 1/2. Step 4. Once more, convert from logarithm to exponential form. So x equals 3 to the power square root of 3. Write the solution set. D equals the set containing 3 to the square root of 3. Domain check. The base of the first logarithm is log base 3 of x. A logarithm's base must be positive and not equal to 1, so log base 3 of x must be greater than 0 and not equal to 1. That means x greater than 1 and x not equal to 3. Our solution 3 to the square root of 3 is bigger than 1 and not equal to 3, so it is valid. Let's mark this as an example. Then we will write problem 1. We begin by converting the logarithmic equation to its exponential form. That gives -1/x equals 1/3 squared. Simplify the right side to 1/9. Solve for x to get x equals -9. Finally, perform the domain check. The argument of the log, -1/x, must be positive, so x is less than 0, which confirms x equals -9 is valid. Now, we follow the second solution in the image. Write the second problem. First, rewrite the square root as a power of x. That is log base x to the 1/2. Use the change of base power rule to get 2 times log base x of x minus 2. Move the 2 inside the log as a power. Log base x of x minus 2 squared. Apply the identity x to the power log base x of a equals a, which gives x minus 2 squared equals 9. Take square roots to obtain absolute value of x minus 2 equals 3. Split into 2 linear cases, x minus 2 equals plus or minus 3. Solve them to get x equals 5, or x equals -1. Finally, check the domain of the original log. We need x greater than 2, so only x equals 5 remains. The solution set is 5. Example. Our first equation is log base 2 of t plus 2 plus log base 2 of t minus 2 equals 1. Step 1. Combine the two logarithms using the product rule. That rule says log base b of m plus log base b of n equals log base b of m times n. Applying it gives log base 2 of open parenthesis t plus 2 close parenthesis times open parenthesis t minus 2 close parenthesis equals 1. Step 2. Simplify the product inside the logarithm, because t plus 2 times t minus 2 equals t squared minus 4. Step 3. Convert the logarithmic equation to exponential form. Log base b of m equals c is equivalent to m equals b to the c. Step 4. Evaluate 2 to the first power, which is 2. Step 5. Add 4 to both sides to isolate t squared. Step 6. Take square roots to solve for t. Step 7. Check the domain of the original logarithms. Step 7. Check the domain of the original logarithms. Both t plus 2 and t minus 2 must be positive, so t must be greater than 2. Negative square root of 6 is less than 2 and is not acceptable. Therefore, the valid solution is t equals square root of 6. Problem 1. The equation is log of x plus 1 plus log of x minus 1 equals 1. We'll proceed in numbered steps, beginning with the domain. Step 2. Combine the two logarithms using the product property. Log of a plus log of b equals log of a times b. Step 3. Simplify the argument using difference of squares. Step 4. Convert the logarithmic equation to exponential form. Since the base is 10, log base 10 of x squared minus 1 equals 1 implies x squared minus 1 equals 10 to the power 1. Step 5. Solve the quadratic and then check the domain. Now the second example. Open parenthesis x plus 2 close parenthesis times log of x minus 1 equals 0. Again, we begin with the domain, then apply the zero product property. Apply the zero product property. A product equals 0 if and only if one factor is 0. Solve the logarithmic branch by converting to exponential form. Log of x minus 1 equals 0 means x minus 1 equals 10 to the 0, which is 1. Finally, check both candidates against the domain x greater than 1. -2 fails the domain. 2 satisfies the domain. The solution set is the singleton containing 2. Summary. For logarithmic equations, always. 1. Enforce the domain by requiring arguments to be positive. 2. Use log properties to combine or separate terms. 3. Convert to exponential form when a single log equals a constant. 4. Solve and then check candidates against the domain. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.